Alright, we're going to start out with, first of all, just defining what a polynomial is. And we're going to kind of look at a little setup here where we have f of x equals, and we'll just read this, a sub n x to the nth power plus a sub n minus 1 times x to the n minus 1 power, and so on, out until we get to a sub 2 x squared plus a sub 1 x to the first plus a sub 0, which is our constant. So this is going to be the general format for a polynomial. Now, a couple things on here. All the a's are real numbers, and they're all integers. So we've got that set up, and the exponents are also integers and always going to be positive as well. Now, a couple things that you've seen already with polynomials in the past. You've maybe had something that's looked like this, where there's our ax to the n plus a sub 0. This one is linear. We might have something that looks like this, where g of x is just 5. That's a constant. We might also have something that takes on the form of something like this, which is a quadratic. And there's many, many more. But again, on each of these, the name is just based on whatever the highest exponent is for that problem. So in this case, the highest exponent was a 1, made it linear. Highest exponent here is a 0, so it's a constant. Highest exponent here is a 2, so it's a quadratic. Right. We're going to work mostly with quadratics today on this lesson. So our quadratic function is going to look like this. Oops, that should be an equals. Alright, now a couple things, like we said, we're going to mainly focus in this first part on defining this. So f of x equals ax squared plus bx plus c. Its graph is a curve, either this way or this way. And then that graph is known as a parabola. And there's a couple things that we can look at on here. With the parabola, we can split it down the middle, and that's known as its axis symmetry. The one that I've got here, we would say opens up, and this one obviously then opens down. Now, a couple things with this. The a value on this side is going to tell us quite a bit about this parabola that we're eventually going to end up with. For this one, when it opens up, a is a positive value. Here, when it opens down, a is a negative value. Now again, there's going to be a lot more that we'll talk about with this, but that's just the starting point for what a parabola is and for a quadratic. Now, one of the general forms that we can deal with here is going to be one that looks like this. One of the easiest quadratics that we know of is one that takes on this form, y equals ax squared. Notice we've dropped any of the following terms in this polynomial. Now, one thing is, anytime we get the x squared all by itself, the vertex is always going to be at 0, 0. Now, a couple things are going to happen. We're going to try and start this off of a parent function, and we're going to take a look at a and see, other than just opening the parabola up or opening down, we're also going to see a whole bunch of other transformations that can happen based on that. So one thing we want to do is we want to base this all on the parent function. So for our parent function, we're going to start this one out something simple. So we get our axes set up here. And then all we have to really deal with for the parent function are a few points that you want to try and remember. And the parent function that we're going to deal with for a quadratic, f of x or y equals x squared, where our a value is 1. So a couple of these values, 0, 0, 1, 1, 2, 4, and then their mirror images on this side, negative 1, 1, negative 2, 4, and we can take this up a little bit further if we want to and go to 3, 9. And negative 3, 9 is its mirror image. And again, where do those points come from? Plug in your x, square it, get out your f of x or your y. So 1 squared, 2 squared is 4, 3 squared is 9, and so on. So we'll end up getting our shape that's going to curve this way, and then it's also going to work its way up on the other side of the graph. So there's our parabola for our parent function. And again, the quicker you can learn these points, the easier it is to do some of the transformations that we're going to deal with. Because everything is going to get based on these points for some of the transformations that we do. Alright, so this is known as our parent function, and again that just means that everything that we deal with for parabolas and for quadratic functions is going to come back to this original graph. Alright, let's take a look at some of our earlier transformations that we've done. And let's switch up our colors here a little bit. A couple of the earlier transformations that we did were, we could have had something like this, f of x equals 2x squared. Or we could have had f of x equals 1/2 x squared. Since it's not contained, the 2 or the 1/2 is not contained in parentheses, it's going to have an effect on the y. So all that's going to happen on each of these is, since it's affecting the y, these are going to be vertical stretches or shrinks. And this is from one of the earlier chapters, so it shouldn't be anything new. We could also have something that looks like this. And again, remember all these are up and down, so more vertical, but since we're doing the adding here, it's just a vertical translation. So it's going to move up 1 spot or down 7 spots. Up here we would just take every one of our parent function y values and multiply it by 2, all of our parent function y values and multiply it by 1/2. We could also end up with something like this, where we go inside the parentheses and again inside affects the x's and does the opposite. So on each of those, the x's are horizontal, so these are going to be horizontal translations. And there's more that we could always go back and look at, but all of these are going to affect the xy values that we had on our parent function here. So that's going to kind of set us up for what our graphs are going to look like.